this is a data analysis course. So if I say gradient descent, then I should briefly talk about stochastic gradient descent also. We'll come back to this again, but I'll just say what is stochastic gradient descent. It's called SGD, right? In fact, when you say model.fit in your, let's say, TensorFlow, you pass this SGD as an argument, right? What it's saying is, in the background, I'm going to optimize my loss function with respect to neural network weights by following what is called gradient descent. In fact, what is called stochastic gradient descent. So what is stochastic here? Can somebody guess what is stochastic here? What is stochastic? All of you have taken introduction to probability, whatever equivalent course, right? Data analysis. All of you. Then what is stochastic? So it refers to randomness, right? So there is some stochasticity. It says stochastic gradient descent. That means gradient distance, there is some noise. So when can that happen? See, in this kind of algorithm, what you do is, when you implement gradient descent, there is another subroutine which will give me gradient, right? I'll query point X, the function will give me the gradient at that point, right? That's a subroutine or a function that you write. Those functions are always deterministic, right? Typically, for example, if you have X transpose QX, right? You look at the gradient of that, it will always give me QX. For a given X, it will always give me QX, right? It won't give me different values. That's called deterministic, no change. What is stochastic? Suppose I query, I ask you to find the gradient at a point X now, you'll give me something. If I ask a little later, you'll give me something else, right? It's noisy, it fluctuates. Why does it fluctuate? Okay, so just a quick background. Again, this is not the main topic. So remember this, so whenever we dealt with neural network, we wanted to minimize the loss function with respect to the neural network weights, and expectation is with respect to some data, right? So you are taking expectation with respect to data, right? This is a true average. Well, if I knew this true average, there is no scope for machine learning, right? You already know the answer pretty much. But what happens is you don't know the true expected value. For example, I give you a coin, right? If I know the bias of the coin, there is nothing, right? So you already know the bias. But what is interesting is, suppose you don't know the bias. Bias is probability of head. If you don't know the probability of head, what do? You toss it so many times, count the number of heads divided by the total number, right? That'll give me an estimate of the bias. Is that fine? So if I toss it more number of time, my accuracy of estimate is good, better, right? Even here, if you have a lot of data and I do the sample average of the loss function with respect to lot of data, I get the average which is close to true average, right? And then I have to, suppose I have, let's say, very huge data, big data, and then I compute the empirical average using that big data. That empirical average is always almost close to this average. Now I say you find the gradient. What is the problem? You have to find, so this is the proxy, right? So 1 over, let's say, n, I equal to 1 to n, sorry, capital N, loss of Zi, right? For each data point, you find the loss and compute the average. This is what you do. Instead of using this, you will use this because you don't know the true average. But if n is very large, and I ask you to find the gradient, what is the gradient? How do you find the gradient? 1 by n, I equal to 1 to n, gradient of this loss function with respect to w. Now you have to find the gradient with respect to w for each data point. If there are, let's say, 10 million data points, then you have to find 10 million gradients. Do you think it's easy? I mean, it's easy meaning conceptually easy, but if you want to, let's say you are training a very deep neural network, that means there are 10 million coefficients, a vector of 10 million, that's the number of coefficient neural network weights, that is your W. and you also have, let's say, 5 crore data points.